Welcome, everyone. This session is on securing SUSE Linux Enterprise against zero-day attacks. My name is Rui Maximo. I'm Director of Solutions Engineering at Polyverse. We're a market leader in security for Linux. And with me is Dan Elder.
Hi, everyone. Thank you for taking the time to watch this. I'm Dan Elder, as was mentioned. I'm a senior engineer with Novico, specializing in Linux services. And we are a professional services provider that does a lot of work in the security space, which is one of the reasons we're excited about this offering and want to make sure you know what it is and how it works.
Great, thank you. Well, problem today is that there's over 1 million unpatched vulnerabilities. And of those vulnerabilities, there's going to be a lot of them that are going to be used by attackers. Now, the problem is that everybody has the same copy of the operating system, whether it's SUSE or Red Hat or any other variant of Linux. And nearly 80% of those attacks are memory-based attacks, which are the most lethal. From an attacker perspective, it's break once and run everywhere. We're excited to be able to have this session because we're introducing, as part of our offering, support for SUSE Linux Enterprise Edition. And here we'll show, as if you navigate to our website on polyverse.com, you can see what type of vulnerabilities are available or exist in the different versions of Linux. And I'll go through that a little bit later. So let me just jump in and talk a little bit about what stack smashing is. In a normal stack, what actually happens is when a function gets loaded or gets called, the function arguments are loaded onto the stack and they fill downwards. So you got the function call arguments, then you got the return pointer, which tells this where to go back once the function is done running. And then with it, there are going to be all the buffers that function loads up. So you'll see here buffer 1 and buffer 2. So when an attacker smashes the stack, what does that mean? Well, they're able to insert through a buffer overflow some code of their own, which in this case, for example, they have inserted into buffer 1 some shell code. And as part of that, they overflowed the buffer so that they overrode the return pointer, which points it back to buffer 1. So when this function executes and then it's about ready to terminate and finish and go back to executing the previous function, that return pointer now points back to buffer 1. And so what happens is that the attacker has hijacked the operations of the application during runtime without having to download any code or create any files onto the operating system. It's all in memory, which is really lethal because it's difficult to monitor and detect. So what the problem is today, all the operating systems are clones of each other. So once an attacker is able to craft an attack for one system, they can perform that same attack for every other system that's identical to it. And so as a result, once an operating system is compromised, everything is compromised. All of them are. In the case of Polyverse polymorphing, it immunizes your software stack through continuous diversity. So what that actually means is at the binary level, each version is unique and not the same. So an attacker who attempts to create an attack for one version of the operating system, that attack would not work on another version of the operating system that's been polymorphed. And how do we do that? We take the source code and we take the dependent libraries, we compile and we scramble it and create this polymorphic version of a Linux package. And so each package is going to be unique because it'll be uniquely polymorphed, and the instance would be different per installation. What that creates is binary diversity. It is logically equivalent, but it creates unique instruction sets at the assembly level. And you can see that this function here logically has been compiled into 3 different assembly instruction sets that are equivalent. So let's jump into a demo. All right, so we're going to do a demo of a buffer overflow attack on a SUSE Enterprise Edition server. On the left-hand side, you'll see that I have SUSE Linux Enterprise Server version 15, SP1. And on the top right, I'll have my attack server. I've generated a payload over here of for taking advantage of the buffer overflow that's been inserted into a libc library. And then on the bottom, I have a netcat that's going to listen to. once the attack occurs, I'll be able to have full control over the victim server. So my vector of attack is going to be SSH. So I'm going to SSH as root onto this server. Instead of the password, which I don't know, I'm going to paste in that string that I just copied above. And I'm going to hit enter. If you notice right away at the bottom on my command and control server, the command ls just executed. I'm actually going to navigate to the root folder here, and I'm going to see the contents of it. And just to verify that I have indeed been attacked, you can see that the contents is the same. I'm going to create a file here called victim.txt, and I'm going to say, I have been hacked, and save this file. What we're going to do here is I'm going to cat that file to see whether I have it. And sure enough, there it is. So, and I can certainly have control on either way, either direction of the victim server. So let me now go ahead and polymorph the system so that it is protected against this buffer overflow attack. I'm going to run this command here. Oops, that's the wrong command. And this, what we'll do is it's going to go and pick the packages that have been polymorphed for specifically for Linux, SUSE Enterprise Edition. Okay, now it's done. So I'm going to refresh my connection over here. And perform the same attack that I had previously. I'm going to paste in the same string that I had over here, which is the buffer overflow attack against this vulnerability, and pass it into the password field. You notice that nothing's happened. I'm still not able to see any contents for it. I can't perform any commands. And so that's an indication that even though the package has not been patched and the vulnerability still exists, because of the sheer fact that it's been polymorphed, the attack no longer works because it relies on the ability of knowing where the instruction sets are on the stack. And that's the end of my presentation for this demo. So let's go back to our presentation. And Dan, it's all yours.
Great, well, thank you. I hope that the demo was as scary for you as it was for me, but it's nice to see we do have solutions for that particular problem. But that is, again, security is a layered approach. So it's great that we can prevent buffer overflows or mitigate the damage from them, but there's a lot more to the security and threat landscape than just a single element. There's no silver bullet for everything. So how do we leverage this new capability and take advantage of that and integrate it with SUSE and the entire Linux ecosystem and leverage all those built-in tools that the system already has? So the first thing to understand is buffer overflows are still possible. They just don't lead to a pre-crafted exploit the way they did before. So what happens in the new situation is that you will see seg faults where applications crash rather than giving remote attackers access to anything. And being able to see those seg faults and capture that in the logs is a critical way of determining, is something bad happening on my system? Because applications shouldn't be crashing like that. And if they are, it's likely because someone's doing something bad. If we can see those in the logs and we can capture those centrally, and we can feed that in our SIEM environment or generate alerts off of it or gather that operational intelligence, that gives us really good ideas of what's happening in the environment, even if it's a zero-day exploit and there's no patch available. So being able to use those native logging capabilities, whether that's our syslog, syslog-ng, taking advantage of the audit daemon for other security events, really being able to capture that intelligence, feed it somewhere centrally, and take action on it is going to really help you secure that environment. So logging, again, always a critical component. Other pieces, though, as you saw, we can do a quick, easy command to patch a system. But what happens when you've got 50 systems or 100 systems or thousands of systems? You need central management. And not just for patching, you need central management for configuration management as well. So again, SUSE Manager is a great tool to integrate with this, because that way not only can we polymorph our systems, we can polymorph them centrally. And having that integrated capability is going to help us keep secure, as well as auditing and all the other components that are needed to really ensure your environment stays safe. because even if we're not applying patches right away, being able to see what's not patched and whether it's polymorphed or not can give us that assurance of whether it's vulnerable or not to a new exploit. So central management, of course, always critical. Another great component in SUSE Linux Enterprise is AppArmor. So mandatory access controls are a really important component, and the reason for that is a simple axiom of a good program does what it's supposed to do, a secure program does what it's supposed to do, and nothing else. And AppArmor is that nothing else. So by putting mandatory access controls around your applications, regardless of whether it's a buffer overflow or some other type of exploit, even if it's a configuration error, that application, that executable, can only ever do what you've allowed it to do. It doesn't matter if it's running as root. It doesn't matter how it's set up anywhere else. All that matters is what's set in that AppArmor security profile, and the application can never exceed those capabilities. So again, a really important built into the operating system capability you can take advantage of as another layer of security on top of this. And then having something polymorphed is great. You've got a physical system or a VM or whatever else you have around that. Those are all really important things that you want to make sure you're securing. But we're moving into the new world of containers as well, or building and distributing applications in various ways. And so we need to be able to do more than just treat something as a full-blown OS. We need to be able to build our containers or build whatever other application environments we're working on such that they're already polymorphed out of the box. So integrating with things like Open Build Server or your container environment, having that audit capability, building it in and integrating with containers as a service platform. All those different integrations are really important so that you make sure you're polymorphing the entire environment, because you don't want to just hit one point. You've got to cover all of them because you're only as secure as your weakest link. So these are some of the tools around SUSE and some of the integrations that you can do. This is one of the areas that Novacoast can help a lot with if you need it, is really integrating all these other security solutions into it together so you have a more holistic way of securing your environment, and you're not just catching the little one-offs here and there, but building something total around everything.
Thank you, Dan. Polyverse offers a comprehensive security for Linux, from the operating system level all the way to the application, against memory-based attacks, scripting engine attacks for WordPress, as well as for AWS Lambda functions, fileless attacks, and even misconfigurations. In partnership with Novacoast, we're excited to be able to support SUSE Enterprise Edition's Linux, and we're looking forward to working with you guys. Let us know if you have any questions. Thank you.
Thanks, everyone.